Hey everyone, good afternoon, good evening to all my dear students and welcome back once again to Buddy Education. So guys, last time we have started an amazing concept which is Heron's formula, and we have discussed a lot many things about this chapter, that why and how this chapter comes in the existence, what is the importance of learning Heron's formula in many real life situations, and how we can actually apply Heron's formula in different scenario, right? And at the end we have started with the application portion of this chapter, and today in the continuation we are going to solve few more questions by which we will get the maximum confidence in this chapter. All right, so let me have a quick check on the sound, whether I'm audible, visible. Give me a quick thumbs up in the chat box so that we can begin with the part 2 of Heron's formula. All right, so let me have a check on the sound and then we will begin with this chapter. Okay, all right, so just allow me 10 seconds. Okay, yes. All right, so everything is good to go. So now let's begin this chapter. Okay, so we are directly going to start with the problems only, because you know that this is that chapter that is having only one formula, and if you are okay with that formula, if you are clear with that formula, nothing else is required. And in the part 1 we have discussed completely this portion of the chapter, that how the formula is being applied in different kind of problem. But still today we are going to solve some more fabulous problem by which we'll be all clear with this chapter. Okay, so without any further delay, let's begin with the first question. And the question is like, a kite is in the shape of a square. All right, okay, with a diagonal 32 centimeter and an isosceles triangle of base 8 centimeter and side 6 centimeter to be made of 3 different shades as shown in the figure. How much paper of each shade has been used in it? So I'll explain and read this question for you. So what they have given, that ABCD here is a square, okay, and its diagonal is equal to how much? 32 centimeter. Now we know certain properties of square, that all sides are equal. All right, and if one diagonal is 32, so you can let it be as AC or BD, okay, any of them. And an isosceles triangle which has been given in the base, they are saying that one side is 6, so of course the one more side will be equal to 6, and the base is equal to 8 centimeter. Now what they are saying, that this whole diagram is made up of 3 different papers, okay. One has been used over here, one is being used for this part, and one is used for the upper part. And now we have to tell the area of the paper that has been used in this question. So for this, what we'll see, that here the diagonals of a square, right? We have to recall the properties of the diagonal of a square. We know that they are equal first of all. So if one diagonal is given as 32 centimeter, namely suppose BD, okay, then of course AC will also be equal to 32 centimeter. One more property that the diagonal of a square holds, that they are the perpendicular bisector. Means what? This angle is 90 degree, and perpendicular bisector means this whole part C to M and M to A is equal, and DM is equal to MB. So we'll remember that if this is 32, definitely this part will be how much? 16. This part will be how much? 16, and this part will also be 16, and MA will also be 16. Now this is one thing that is going to help us to find the area of the paper used in this question. Next is what? Here we can, so this is the basic information that I have told you, that CM and MA, they both are the half of AC in a similar pattern. So that's why CM will be equal to 16 centimeter, which we will use for finding the area of this, okay. Now if we want to find the area of the upper part, for example, okay, this is a this is an triangle, okay, and the triangle's area can be found in two ways. First, if you have all the sides, you can use Heron's formula. Second, there is one more basic formula that we used to use earlier, is half base into height, and over here you can see that this is the base and this is the height. So we have both of these things. So do we require to use Heron's formula here? So answer is no. If you have height, if you have base, you can directly use the normal formula for finding the area. So now we will write all the basic information. Suppose here we have used a blue paper, and here in the second part we have used a yellow paper, and in the third part we have used a green paper, okay. Now what information? First we'll find the area of part 1, which is this. This is part 1, this is part 2, okay. Now we know that here the area of shade 1, shade 2 and shade 3, if we'll combine them, we'll get the area of the total paper that has been used in this question. Alright. Now we know diagonals of the square divided into two equal parts, right? We know that if we will draw a square and if we will make a diagonal, okay, that diagonal will divide the whole area into two equal parts. Means what? If I'll get the area of the first part, I'll certainly double it to get the area of the whole square, okay. Means the area of the part 1 and part 2 is equal. So you can find for any one of them, and by default you will get the area of the second part. Alright, in this way what we are going to write, so this is what we have already discussed, that area of triangle CDB, which is the upper part, that is equal to the area of the shade 2, because they both triangles have equal area. Alright, now what is the area of the triangle? It is half base into height. Now you can see this base is diagonal and the diagonal's value is how much? 32 centimeter, okay. So here the diagonal BD is equal to 32 and this height CM is equal to how much? 16. So we will multiply it by 16, and when you will solve this, okay, this will be 2 into 32. When you will divide 32 by 2, you are going to get 16. 16 into 16 is 256 square centimeter. But this is the only area of the first part, and we have discussed that the area of shade 1 and area of the shaded part 2 is equal. So the total wholesome area for both of these we can add, okay. Now let's move to the third part. Now here you can certainly see that we can't use the formula half base into height, because we have the base but we don't have height over here. So here one more information is given, that all the length of the sides is given. So here we can certainly use the Heron's formula, and even last time I told you that whenever you are using Heron's formula, it is very important that you write all the portions of the formula. Mean what's the value of S, then the area equal to S, S minus A, S minus B, S minus C to the square root. Alright. So here what we are going to do, we are going to write our formula, okay, and then we'll figure out the value of A, B and C. Now C, let's just suppose A is this, B is this and C is this, okay. So we'll write all these things. So first what we have to do, we have to find the value of S, which is semi-perimeter. So here the semi-perimeter will be like 8 plus 6 divided by 2, which is going to come as how much? 8, 6 and 6, 12, 12 plus 8, okay, is 20, 20 divided by 2 is 10. So we got the value of S. Now we have to plug in all these values in our formula, okay. This is champion formula, okay, hero formula, okay. So the value of S is 10, then the value of S minus A means 10 minus how much? 6. So we'll write the next part, then again 10 minus 6, we get B's value is also same, then S value is 10 and the value of C is 8. So this will be 10 minus 8. Then you will subtract all these parts and then you will get this. Now after this I told you that if at this point of time, if you will multiply and then you will prime factorize, it is going to take a lot of time of yours for the calculation. Instead, what we have to do, we have to just break them down, means we have to prime factorize them. Alright, so here how we are going to prime factorize this, we can write 10 as 5 into 2, we can write 4 as it is, we can write 4 as it is, or you can further prime factorize this 2 into 2. But I told you that both ways work. Either you prime factorize in or you break down in a way that the pairs will be start appearing. Okay, so 4 I have not factorized because it is already having a pair. So even if you will prime factorize it like 2 into 2, you are going to get the same answer, and this is the last 2 that is left. Okay, now you can see that here, okay, here what is left? A square root should be there. All right, now here 4 is having a pair, 2 is having a pair, but 5 is not having any pair, right? So inside the square root 5 will remain same and will get 8 square root 5. Now either you can leave your answer here, or if you know how to find the square root of 5, which you should certainly know, because this is one thing that we have already learned in class 8th. Okay, so if you don't know, you can comment me, ma'am, we don't know about this, can you explain it? So I'll definitely explain it, but I'll request that all of you must know. Okay, so here we will put the value of square root of 5, which is equal to 2.2, and that's how we'll get the area of the last triangle, means part 3, as this. Okay, okay, just wait, as this. So what they have asked, they haven't asked that how much total paper is used. They have asked how many different shade of papers that has been used for part 1, part 2 and part 3 is used. So for part 3, this is 17.6 square centimeter. For part 2 and part 1, this was 256 centimeter square each. So I hope this question is clear to all of you, and it's a very important question. See students, I have tried my best to put in or discuss all of those questions in which most of the students feel that it's difficult and they stuck. Okay, and especially those questions that may appear in your upcoming half yearly midterm examination. Okay, so make sure you are noting them down somewhere in your notes area, or you will pause, you can pause the video, you can take the screenshot and then you can practice and write down in your notes part. Okay, so that before your examination you can revise all those things. All right, okay, now let's move to the next question, and the question is little different, and you can mark this very important question. You can mark this as very important. Okay, this is a very important question, and the question is like, a field is in the shape of trapezium that we can see over here, in which few informations are given. Let's see what all information they have given for this question. The information is like, the parallel sides are given as 10 meter and 25 meter, and the non-parallel sides are like 13 meter and 14 meter. All right. Now what they are asking, they want us to find the area of the field. Now all of us knows that the area of the trapezium is half sum of the parallel side into height. Now parallel sides are already given, so the main problem is with the height. If we will get the height, or if we will know the measurement of the altitude, we can solve this question. And whenever you have a trapezium kind of question, there is this way that is going to help you always. Okay, so you have to be little focused in the class, in today's class, and you have to learn that how we can solve the area of the trapezium by using Heron's formula. Okay, let's see. So for this we have to do little construction in the question. So what we'll do, we can see that non-parallel sides are 14 and 14. So here what we'll do, that first we'll write that the area of trapezium is what? Half sum of parallel side into height, that we already know, but problem is with the height. So first we'll draw, or we will construct the height of this trapezium. So for that we have drawn one perpendicular from the vertex B on the side CD. Okay, and that is striking the side CD at M. Okay, so BM is the height that we are looking forward. Okay, now after this what you are going to do, for this you are going to do some more construction, and for that what you will do, you'll make just wait, we'll make a parallel line. Okay, this is what is going to be done. This is what you are going to do. You are going to draw one line BE which is parallel to AD. This is very important. Now from this what is going to be done, then this part, this portion is what? Now this side is parallel to this was already parallel to this, so they are what? It forms a parallelogram. It means ABDE is now a parallelogram. If this is a parallelogram, so opposite sides are equal. So if AB is 10, certainly this distance is also 10. Now you see what is now we have done, or what is the thing that we have got from here. This whole thing was 25 and this is 10. So this EC is going to be how much? 15. Now you'll say, ma'am, from here what we are going to do and how we are going to proceed with this question. I'm already giving you a draft of the question, then we will start doing it. Okay. So till now, two things you have done. First, you have made one perpendicular from B so that you can get the height of the trapezium. Second thing what you have done, you have made one line BE in such a way that is parallel to AD, and that's how we got this figure as a parallelogram. Now for parallelogram we have certain conditions that opposite sides are equal. So if this is 10, this is also 10. Now if this whole thing is 25 and this is 10, so EC is how much? 15. One more information that we got from here, that if this is a parallelogram, then if this is 13, this is also how much? 13. Now you will say, ma'am, why we are doing it? For this, why we are doing this, I am telling you. Now can you see BEC triangle? Now here, if I want, I can use Heron's formula over BEC. You will say, ma'am, how? Because BE is 13, BC is 14, and I told you EC is how much? 15. So you can get the area from Heron's formula. You will say, yes, ma'am. But I told you that for finding the area of the triangle, the basic formula that we are using from so long is half base into height. So if I take the base as EC, if I take the height as BM, this is also one way to find the area. Now you'll say, ma'am, why we are using two ways? Because if you use even 10 ways to find the area of a certain thing, the area is going to be equal. So we'll get the area from Heron's formula, we'll get the area from the basic formula, we'll equate them, and by which you are going to get that one value which is required for whole this question, which is the height of the trapezium. Now I have discussed it orally, I have told you the path on which we are going to move to solve this question, but now let's solve this. Okay, so we have write a few information about this, and then we are going to write all the things that I have told you, that this BE is equal to how much? AD, and that is equal to 13, and ED is equal to AB, which is equal to 10 meter. Now in triangle BEC, they are saying BM is the height and EC is the base. So yes, now we are going to do what? We are going to find the area of triangle BEC. So the one way that from which you can find the area of BEC is half. Base we are taking as base we are going to take as EC. So this is the base and this is the height. Okay, BM. Okay, now EC is equal to how much? EC, I told you that we have already took it as DC minus how much? DE. Okay, so DC is 25 and 1 is 15, not 15, it is 10, and 25 minus 10 is 15. Alright, so that's how you'll get your EC. Now you can put everything over here in this formula. So over here you can see BM, we don't know, okay, but EC is how much? 15, okay. Now after this what you are going to do, I told you that there is one more way to find the area of triangle BEC, which is Heron's formula. So now I am going to use Heron's formula in triangle BEC. So first we'll find the semi-perimeter. So here one side is how much? 13, another side is 14, and last side is 15, and divided by 2. From here you are going to get your semi-perimeter as 21. Now we'll find the values of under root S minus A into S minus B and S minus C. So the value of S is 21, 21 minus 13, 21 minus 14, and 21 minus 15. When you will solve this, you are going to get this. Now again, if you will multiply, you will stuck. Okay, but apart from that, what we have to do? Instead, what we have to do is that we have to break it down in such a way that we'll get the pairs, okay, of the same number. So 21 we have written as 7 into 3, 8 we have written as 2 into 2 into 2, 7 will keep same, and 6 we can write down as 2 into 3. Now you can see that 7 is having a pair, 3 is having a pair, and 2's are having pair, okay. So they'll all come out of the square root and we'll get the area of BEC as 84 meter square. But you know that the area of BEC can also be found from this way, where BM is we don't know, EC we know it is 15 and the area is now from this way, this is equal to 84. Now if you will simplify it, you are certainly going to get the value of BM as this, which is equal to 11.2 meter. Now we got the things that we were looking for. So now after this we can use the area of the trapezium, which is half into sum of the parallel side into height. Now parallel sides are 10 and 25 and the height is 11.2. When you solve this, you are going to get your answer, which is the area of the trapezium as 196. So basically students, whenever you have the question of trapezium and you have to find the area, this is the way that is going to help you. Okay, all you have to do is the construction and you have to remember that construction. Okay, because if you forget that, then it will be confusing for all of you. So I would suggest that whenever this kind of problems come, which is little tricky and little complex, so I would rather suggest first you have already watched this video, you are studying in the classroom. After that, what you have to do, you have to pause the video and you have to make a mind map for this question. Then you have to do it on the paper, and then I'm pretty sure you are never ever going to forget this. Okay, now let's do the next question, which is on rhombus. So you are seeing that I am making you do different kind of problems. Okay, so for similar question you can get it from your textbook, you can get it from your reference book, and if you don't find it, you can text me, you can comment me in the video, and then I can share you few questions. Okay, all right. So the question is like, we have a rhombus shaped field has green grass hoga, this may be green grass. Okay, one word is missing, this is green grass. So there is a rhombus shaped field in which we are having green grass for how many cows? 18 cows who are grazing together. Okay, if each side of the rhombus is 30 meter, and we know all the sides of the rhombus is equal, so the side is given as 30 meter and its longer diagonal. Okay, so we know that the diagonals are not equal, so they have mentioned the longer one is 48 meter. How much area of the grass will be filled by each cow? Okay, so how much grass or how much area did every cow is going to get for grazing? Okay, so this is our good question. So first we are going to make the diagram for this. So this is how the field is looking like, and there are multiple cows in it. Okay, now we'll name the vertices as A, B, C, D, and we know all sides are equal, which is given as 30 meter in the question. Okay, so this is one information. Next information is about its diagonal. So we'll make the diagonal over here. So just suppose AC is the longer diagonal and it is equal to 48. Now we know that if we want to find the area of the grass that each cow is going to get, what we have to do? First we have to find the total area, and then we have to divide it by how much? 18, because there are in total 18 cows. Okay, so first we will find the area of the total field and then we will divide it by 18. Now we have one more information about the rhombus diagonal. Okay, and the information is like that the diagonal of the rhombus divides it into triangle of equal area. Means if I have drawn this diagonal, then the area of the upper part and the lower part is equal. So even if we get for the one, we'll double it and we'll get the total area. All right. Now, so let's find that area of triangle ADC, which is the upper part. Now, here you can see that one side is given as 30, another one is 30, and this longer side is 48. So we can use what? Heron's formula, because all the measurement of the sides are given. So for this we are going to mention it like ABC, and then we are going to find the value of the semi perimeter, which is A plus B plus C by 2. We'll put all the values of A, B and C, and that's how you'll get your semi perimeter as 108 divided by 2, which is equal to 54. Now we have to plug in all these values in the Heron's formula. I already told you that it is very important to write down the formula. No matter there are two questions coming, but still you will mention the formula each and every time. Okay, so from here we get the value of S 54, then 54 minus 30, 54 minus 48, and the last value is also 54 minus 30. When you will subtract and when you will put it down, it will look like this. Now again I am reminding, do not multiply, instead break down or prime factorize. So here I am prime factorizing 54 as 3 into 3 into 6. Okay, 9 into 6. Okay, then I am writing this 6 over here, and then I am keeping 24 and 24 together because they are already in pairs. So do we need to break it down into prime factor? Answer is no. So if you have certain pair, it is a wastage of time if you are breaking it down. Okay, so from here we get the one pair of 24, we get one pair of 6 and one pair of 3. So everything will come out of the square root and you'll get the area of ADC is 432. Now this is only the area of the upper part, but we told you that they both triangles are having the same area. So what we are going to do, we are going to double this. Okay, so we are going to double the area of ADC, and then further when we will get the total area, we have to divide it by 18 because we want to know the area that has been grazed by one cow at a time. Okay, so this is the area that one cow can graze at that time, which is 48 meters square. I hope this question is all clear. We have done the question on trapezium, we have done the question on rhombus, we have done the question on square, and we have done on the normal triangle. Okay, now we are doing few more questions that after that I'm pretty sure that you are going to be super confident in this chapter, that no matter which kind of question is coming, that is not going to be out of the question that we have discussed in these two classes. Okay, and then we are going to wind up with this chapter. All right, now let's move to the next question. I request all of you to read the question. Meanwhile, I'll take a quick break for water. Okay, I'm coming back till the time you all read the question. All right. So the question is, find the area of quadrilateral ABCD whose sides are like 9, 40, 28 and 15, and they are saying that the angle of the angle between first two side is a right angle. So which is a perfect situation for us, because we know whenever there is a right angle, we can use Pythagoras theorem over there. And even to find the area of the triangle which is having one angle as 90 degree, we can use the simple formula as half base into height. Okay, but for that we have to break it in a way that we will get the triangle, because here if we want to use Heron's formula or the area of the triangle, we should have the triangle. Okay, so for this what we are going to do, this is the portion, total portion for which we want to find the area. So here what we are going to do, we are going to combine A to C. Okay, so here we are going to join A to C, and that's how you'll get this figure. Okay, this, now you can see this quadrilateral is divided into two triangle, one is ADC and another one is ABC. So if we want to find the area of the total figure, what we have to do, we'll find the area of the first part, we'll find the area of the second part, and we are going to add it. Okay, so this is the first portion, and you can see this green portion is a right angle triangle. So the area is certainly half base into its height, which is very easy. And for the second one, we have to use Heron's formula, but you can see one information is missing again, which is the length of AC. So how we are going to do that, how we are going to find that. So you know, if this is a right angle triangle, we can use Pythagoras and we are going to get the diagonal. Once the diagonal will be done, we'll use the Heron's formula for the triangle ADC. So that is the path that we are going to achieve, that we are going to go on for getting the solution. But now let's see how we can do it on paper. Okay, so we'll write all these information, because this is a right angle triangle, so the area is half base into height. So you can see here base is 9 and the height is 40. Okay, so we'll write all these information in the place of AB and BC, and we are going to get the value as 180 meters square. So this is the area of the first triangle that we wanted to find. Now we know if we want to find the area of ADC, we need the measurement of AC, and for that we will be using Pythagoras theorem in the triangle ABC. Okay, so here you can see that AC is the hypotenuse, so hypotenuse square is equal to base square plus perpendicular square. So AB is 9, 9 square 81, and then 40 square, which is 1600. You are going to add them all, and then 1681 is the square root of how much? 41 meter. So now as you get the measurement for the side AC, you are ready to use the Heron's formula in that triangle. So you can let one side as 41, so this is 41, this B is 28, and this C is equal to 15. So first value that you will calculate is the value of S, which is like this. So 41 plus 28 plus 15 divided by 2, that is going to be equal to 84 divided by 2, which is equal to 42. Now it's time to plug in all the values in the main formula, Heron's formula, and then we'll put all the values, we'll do certain calculation that we are doing in all the questions, which is not at all tough for now. But again, recall that part that we can't multiply, we have to break it down. So we'll write all the numbers, and we'll now, either at this step you can prime factorize, or you can break the numbers in a way that pairs will be done. Now 14 is relevant to 42. How? You can write 42 as 14 into 3. So instead of prime factorizing it, you can use this way as well, which will definitely save your time in the calculation portion. 27 you can write it as 3 into 3 into 3. That's how you will get one pair for 14, two pairs for 3. And that's how we'll get the area of the second part, which is 126. Now they were asking not for the individual area, but the total area for this quadrilateral. So for that, in the end, you have to add the area for the first portion, which is the red one and the green one, and that's how you'll get it as 180 plus 126, and your answer is 306 meters square. I hope all these questions are being clear to you, and after this there should be no question that you may stuck in. Okay, now one more question again on trapezium, and I told you the question of trapezium, this trapezium portion is very, very important for your upcoming examination. I am like 99% sure that this will be one of the question. The digits may be different, but this will be that question that is certainly going to come in your midterm examination or in your full term examination. Okay, so let's see the question again. The area of the trapezium, parallel sides are given as 25 and 13, and these two sides are now equal, means this is isosceles trapezium. Okay, now what they are interested in, they want us to find the area of it. Now we already know, if we want to get the area of the trapezium, all we need is the height, because parallel sides are already given. So in this question even we have to do some construction, then only we can get the area of the trapezium. So first we know, we'll write the basic formulas that the area of the trapezium is like this. Now we can see that height is missing, so that's one value that we want to find. So for that we will first draw the perpendicular from, either you can draw it from D or C, you will get the same answer because they are parallel lines. So height between them at each step is going to be same. So we have drawn one perpendicular from C over AB, and that's how you get CF as your height. Now that's what we want to know. Now we'll do further more construction that we have done in the previous question, that we will be drawing a parallel line to DA. Okay, and that's how you'll get this portion as ADCE again as a parallelogram, and we know that opposite sides are equal. So if this is portion is 13, then A to E is 13. Now if this is 13 and the whole thing is 25, you can again get the value of EB. So we are going to write everything that this is a parallelogram, opposite sides are equal, and that's how you'll write the information about AD equal to EC, which is also 15, that we will be using for finding the area of this triangle, okay. And then we will write the information about how much EB, that's the main information that we need, okay. So for this, how you are going to do it, this is 13 and the total is 25, so 25 minus 13, you are going to get it as 12, okay. So this is the value of E to B. Now in the triangle CEB, you have all the sides of the triangle, one is 15, another one is 15 and this one is 12. So you can use, at one side you can use Heron's formula, on the other side we are going to use the same formula, half base into height, and then we are going to equate them. Alright, so for BCE, first I am going to do it with Heron's formula. So the sides are like 15, 15 and 12. So divided by 2, 30 plus this is 42 divided by 2. So you are going to get the value of S is 21. Plug in all the values quickly in the Heron's formula, and that's how they will break it down after that. 21, then 21 minus 15 is 6, then 6 and then how much? 9. Now you can break it down further to get it out of the square root. That will look like this, okay. And after all the calculation, you are going to get the area of BCE as this. Now you can stop here. This is one part you have done. Now again in this triangle, what you have to do, you have to use your normal formula for finding the area of the triangle, which is equal to half base into height. So we are going to equate this thing equal to half base into height. Now base is how much? EB, which is equal to 12. Height we are interested in finding, okay. Height we are keeping it same as CF. Now when you will do certain calculation, you are going to get the value of CF as 3 square root of 21. Now now you get the height. So after all these things, you are ready to use the formula of the area of the trapezium, which is half sum of the parallel side into its height. Now parallel sides are 13 and 25, so that will be added, and CF is how much? 3 into square root 21, okay. So we'll put this value, we'll again calculate all these things, and then you are going to get your answer here. So either after at this step you can put the value of square root of 21 in the decimal portion, or this is perfectly okay to leave the answer over here, but never ever forget to write the units, okay. So there are certain things when you are writing the answer of any question. Few things are important. First, to make the diagram, and that too make sure you are making it on the right side. Second is you are writing down the formula that is being used in the question, and the last thing is this conclusive statement, and it will be very very great if you make a square or a rectangle over it to highlight your answer. Never ever forget to write down the units, no matter you are finding the area or the perimeter or anything, okay. And if you are doing all these things, no one is going to deduct your any of the marks, okay. Now it's time to solve our next question, which is again a different one, a very good question, again on rhombus, but this is little different, okay. How? Now they are saying find the area of the rhombus in which perimeter is given, okay. Now we know that our rhombus is having all sides are equal, okay. So if we want to know the side of it, we will get the information from the perimeter. So they have mentioned it as 80 meter, alright. So this is one information that we are going to use, and they are saying one of the angle is 60 degree. Let us just suppose this angle is 60 degree. Now you must be thinking that why angle has been given. There must be some connection, that's why they have given it. So first what we'll do, we'll say that all sides are equal. That's why the perimeter is going to equal to how much? 4 into one of its side, okay. So we get the side as how much? 20 meter. Now all the sides of this rhombus is equal to 20 meter. Now if we will draw one diagonal of it, we know that if we will draw it, this is going to divide the area of the whole rhombus into two parts, okay. Now and that two equal part, means if I get the area of the yellow part, I'll double it, I'll get the area of the rest of the part, and that's how I'll get the area of the total portion. But now the point is, ma'am, even if we want to use which formula? Heron's formula. So we need either all the sides or if we want to use our normal formula, which is half into base into height, then we need the height. Now you can see height is not given. Even if this is 20, this is also 20, okay, but we don't have anything. This is not a right angle triangle that we can use Pythagoras. So then how we are going to solve this question? Okay, but there is a information which has been given on the angle. Why that has been given? Let's watch. Okay, now in this triangle, can you see that these two sides are equal? Means which kind of triangle is this? Isosceles. And if the sides are equal, the angles opposite to that are also equal. Means in this triangle, I can say this angle and this angle is equal because of being isosceles. And we know in a triangle the sum of all the angle is equal to how much? 180 degree. So how we are going to sum up? 60 plus x is equal to 180 degree. So we'll get it as 2x is equal to how much? 120 degree, and that's how we'll get the value of x, which is amazingly equal to 60 degree. So here the surprise is, now we can see that if they are equal, the angles were equal, and if this is 60, they are also come out as to be 60. Now you can see which kind of triangle is this. This is not only isosceles, but this is an equilateral triangle, and we directly know how to find the area of equilateral triangle. The formula was under root 3 by 4 into side a square, and that was the first formula that we have proved by using Heron's formula. So now you can here at this point of time you can use Heron's formula because we have all the sides length, or you can directly use this formula, which is equilateral triangle area. Side has come out to be equal to 20 degree, and that's how you'll get the area as 100 into root 3. But this is not the final answer, because we told you that in a rhombus, if we draw one diagonal, it divides the whole area into two equal triangle. Okay, so not equal triangle, area triangles of equal area. So for the final area, you are going to multiply it by 2, and that's how you'll get the total area as 200 and square root of 3. At this point of time, either you can put under root 3 is equal to 1.73. That answer is also perfectly okay, or you can leave the answer here. But never ever forget to write the unit, never ever forget the conclusive statement of the question. Okay, and that's all in this chapter. I am pretty sure and that no question is going to come out of these questions that we have discussed in part 1 and part 2. And if any of you have not watched part 1 yet, you can go and watch out, alright, because there we have discussed that how this formula works, we have discussed all the fundamental, we have also discussed many questions over there. And make sure to note down all these questions that we have discussed in these two parts. And guys, now we are done with this chapter. Alright, so now I'll see you all in my next video. Till then, bye bye, take care everyone, good night.